Numerical. In the safety simulation of heat transfer, the predicted heat flux is 4.35 kilowatt per meter square, while the analytical solution gives 2.5 kilowatt per meter square. So after mesh refinement, the predicted value improves to 2.42 kilowatt per meter square. Analyze the reduction in discretization error and estimate the asymptotic value using appropriate and extrapolation method. Based on this, evaluate the total numerical uncertainty and comment on the reliability of the simulation results for design purposes. So first step is to calculate the error analysis or to carry out the error analysis of initial and refined mesh. So given data is there, analytical value is 2.5 kilowatt per meter square, and initial results we are having, that is phi2 is equals to 2.35, and refined mesh values we are having phi1 is equals to 2.42 kilowatt per meter square. So first step we are talking about the error calculations. So discretization error will be calculated based on the exact value minus the mesh result value. So if initial mesh we are defining, so E2 is equals to phi exact minus phi2, which gives the 2.5 minus 2.35 is equals to 0.15, and for the refined mesh we are having exact mesh minus phi1, so 2.5 minus 2.42, so I am getting 0.08 kilowatt per meter square difference, it deviated from the exact analytical results. So the error reduced from 0.15 to 0.08, which shows the improvement after mesh refinement, right? So error reduction will be the percentage in terms of percentage, and the reduction is 0.15 minus 0.08 is equals to 0.07, and in the percentage reduction it is 0.7 divided by 0.15 into 100. So the percentage reduction is 46.67. So error is reduced by about 46.67 percentage, indicating better accuracy with the finer mesh. Now come to the asymptotic values that Richardson extrapolation method we used previously. So we are assuming the order of accuracy P is equals to 2. Refinement ratio here also we are taking R is equals to 2. So based on that, exact value for the phi is phi1 plus phi1 minus phi2 divided by R to the power P minus 1. So I am getting the value of phi exact 2.4433 kilowatt per meter square. This is the estimated exact solution if the mesh becomes infinitely fine. So now GCI we have to calculate, which is of Fs phi1 minus phi2 divided by phi1 into 1 upon R to the power P minus 1. Now this value we are calculating, and I am getting 1.21 percentage as a GCI values. So as we are observing, the GCI value is about 1.21%, which is very small. So this means the numerical uncertainty is low and solution is close to the exact value is reliable. So mesh refinement significantly reduce the error. Extrapolated value is close to the analytical solution, and low CGI confirms that simulation results are accurate and suitable for design purpose. So as we discussed previously, Fs, which we used for calculation of GCI, we can take as a 1 point, Fs is equals to 1.25 for your numericals, right? And similarly R you can assume always in the range, that is the value 2.